of these sessions are being recorded, and if there are any that you missed and that you want to see, just let me know and I will send that to you in the follow-up email after this talk. I also send links to all of those recordings in case you're ever interested in them. So with that, I am going to share my screen. Does that look like slides to you guys?
It does indeed.
Awesome. Okay, so today's talk is the last talk in our Good Bad Bugly in our Bull City Gardener talk series. This has been a lot of fun. We've covered a lot of different topics. This is one that is a personal favorite of mine. I had a brief moment in my life where I thought I was going to become an entomologist and study insects until I realized I liked them too much and I didn't want to spend all my time killing them. So, so it goes, right? So just if you've been to these talks already, you'll know the next couple slides by heart at this point. But one thing before I get started, I get excited about this talk and I tend to just go off. We will be doing questions in the chat. If you have not done chat on Zoom before, there should be a button probably at the bottom of your screen that is the chat, and you can put your questions in there. Monica will be helping to answer those and also kind of compiling for the end. Monica is our fearless master gardener, kind of wrangler behind the scenes, which is awesome. We'll be, the talk is 2 hours long, which can be long, but we will have a short break in the middle to kind of stretch legs, get a drink, any of that kind of stuff. So hopefully it's not too long. So with that, I just want to note that even though this is the last Bull City Gardener talk online, we actually still have a full talk series lined up to happen out at Briggs Avenue Community Garden. We are not having one in June, but starting in July, we will have a talk, and then September basically through November, we will have talks on all sorts of different topics and kind of hands-on stuff. And those are fun because those are just 1 hour sessions. You get to hear 2 different small talks. So it's a great way to just kind of get your feet wet on a topic, which is really fun.
Ashley, who does those?
Master gardeners do those. So veggie garden problem solving. I will be doing that one with support from other master gardeners. That's a fun one because you'll be able to bring your weird plant problem and we'll help you diagnose it. I like to think of it as veggie garden CSI. Succession planting is Catherine Hamilton. We also have Beth Austin. It's a kind of a collection of master gardeners, all who are super talented in the topics we've chosen for them. And they've been really, really fun so far.
Awesome, thank you.
Yeah. No, those are super fun. And so part of this is also just getting to know that cooperative extension is this bigger thing, right? It's not just me giving talks from this office that you guys might have seen, but we are actually a nationwide network of researchers, educators, and volunteers. And so we are kind of the outgrowth of, in this state, NC State, and also NCA&T, 2 of our land-grant colleges and universities. These are schools that are really, really charged with doing research that people can use in their everyday lives. And we as Cooperative Extension partner with those universities to make sure that research actually gets out to you, right? So the whole idea is that not only is it good to research how to grow a better blueberry, people should then go out and explain to you what has been found out about how to grow better blueberries and to work together and kind of put that into practice. And so here in Durham County, we are a partnership between the land-grant institutions and the county itself. We get a lot of funding from both. And we have an amazing master gardener program. This is a picture of us on the right, out working in our demo garden out front of the building. It's a great group of folks, about 100 volunteers that really do a lot of the heavy lifting on getting that material out to the public. So if you ever have questions for master gardeners, if you're ever what's this weird insect, or what in the world's going on with my leaf, right? You can always reach out to the master gardeners, and they are all super trained volunteers who can answer all of your questions, or at least point you in the right direction of who can answer them. That's all our thing, right? We might not know the answer, but we can figure it out. We'll work with you to figure it out. One super exciting thing I would like to point out is that we actually now have office hours again. For a while, we didn't have office hours, but we do have office hours now from 9 a.m. to 12:30 p.m. Mondays and Wednesdays. And that's actually drop-in. So if you have this strange insect in person, right, you can show it to us. That's really fun. If you want to ask questions in maybe a less hands-on way, you can always email or call. We also run a number of social media and kind of online platforms. So we have a blog, we have Facebook, we have Instagram, where we're posting to-do lists for the garden, interesting things about plants, interesting kind of facts that you can use in your own gardening, all sorts of different kind of outreach material, and how you can ask us questions through those platforms. So please check us out. It's a cool group of information and a cool group of pictures, and those are updated regularly. So without further ado, insects. I love insects. So today's talk, we will cover all about insects. So this is kind of an insect primer. What is an insect? Insects in the ecosystem. Who did this? It's one of my favorites. Getting to know the neighbors and learning to live together is our final topic. And so I will openly admit that partially, mostly due to my own love of insects, some of this talk is definitely going to be about managing insects, figuring out how to control them, figuring out how to have the outcomes you want in your garden. And a lot of this talk is going to be about like, insects are awesome. Here's how we can support insects while still not having them just take over everything all the time. So kind of how we can live together. So first and foremost, what are insects? I come from kind of a evolutionary biology background, so I love this kind of figure. Not everyone does. But what is really fascinating about this is if you think about what insects are, it's really helpful to know kind of who their closest relatives are, right? So for insects, right here, they belong to a group of animals called arthropods. And so some of their closest relatives are things like worms, snails, things that you wouldn't think of being similar to them at all. But that's because when you zoom into the arthropods, there's a lot of the usual suspects of things that look insecty, right? So you have things like trilobites, spiders, crabs. I always like to think of crabs and lobsters as like sea bugs because they really are kind of like sea insects. And then you finally have the insects themselves, right? And part of what I think have always thought is really, really interesting, this is like just like a insect fun fact about the evolution of insects, is that in a lot of the ancestors of insects, things like the trilobites, and even now the millipedes and centipedes, they have a tremendous number of segments, right? Like they have so many legs, so many little segments, whereas insects always have 3 segments and 6 legs. And the idea is actually that as insects evolved, they reduced the number of body segments, often combining body segments, which is why, like, if you were to look at an insect's head on a trilobite or a myriapod, what is actually 5 segments, they've compressed on into 1, which I just think is cool because it's like, this is what happens if you simplify this, which I just love that. So insect diversity, all-time favorite quote, the creator must have had an inordinate fondness for beetles. That was an evolutionary biologist named JBS Haldane. And so there are about 6 to 10 million species of insects. We really don't know how many there are, and we're finding more all the time. This is probably actually a really conservative estimate. There are about 1 million described, so 1 million that we have like put names on. And of those 1 million, almost half, 400,000 plus, are beetles, right? Like the world is actually mostly beetle with some other stuff mixed in, right? So this is insects. This is everything not an insect, right? This is mammals, that little like slice you can't even see. So that compares to over 390,000 species of plants, right? So there are more beetles than there are plants, right? That's how many beetles there are, that's how many insects there are. Of the plants, about 25,000 of them are orchids, which is actually really interesting. The orchids are a very, very, very diverse group. Putting that in the context of mammals, because we are mammals and we like to think of it things that way, there are about 5,400 species of mammals, right? So there are like 5 times as many species of orchids as mammals, pales in comparison to the number of beetles, let alone insects. And fascinatingly, of mammals, like 1/5 of the species are bats, which maybe is scarier now that we know about what we know about COVID, but whatever, don't think about it, it's fine. So there are a tremendous number of bats, right? One of these species is humans, right? So if you think about just the tremendous amount of insects that are present on the planet, it's pretty clear this is an insects world, we just live on it. And of those, less than 0.1% are considered serious pests. So the vast majority of those insects are just out there, living their lives, doing their thing, right? Not causing any trouble whatsoever. Sometimes just like living their best lives, and that's great. And the way that insects go about doing that is actually really fascinating. So if we think about the anatomy of an insect always has 3 body segments and 6 legs. So if you look at something and it looks like a creepy crawly and you count up the legs and it's 8, not an insect, right? Just can't be. So if you look at this kind of on an ant, this is really, really typical, where you have the head, the thorax, and then the wing, and then the abdomen, and the legs are kind of attached here in the middle. Don't be confused. These are antennae, not legs, right? So it's always the same. On some insects, it's a little bit confusing. This guy here is a shield bug, and it looks almost like he's got one major body segment and maybe like a head up here, so maybe 2 segments. But if you were to flip that insect over, you would actually see the clearly delineated body parts, right? It's just, these are actually its wings overlaid on top, so you can't quite see through. And so this is a talk that's adapted from one that Matt Jones in Chatham County gives. And I always love that he was like, you know, it's still a bug, even if it looks funny on the outside, right? Like if you go into the inside, it is still a bug. It's still got 3 segments. It matters what's underneath, not what the shell is. The ultimate confusing insects, well, they are insects, but they're definitely confusing, are a lot of the caterpillars and grubs. It looks like they have all these funny little legs in the back, like, you know, how when an inchworm inches over and it's holding onto you with its back legs, and you're like, wait, there's 6 legs in the front. What are these things in the back? They are prolegs. Fun fact for those keeping track at home, they are not real legs. They are weird fleshy outgrowths that they use like legs, but they're not considered legs. So even a caterpillar only actually has 6 legs. I don't know what the story is with the body segments. I think they just get away with it because they're caterpillars and they're intermediate stage, but definitely only 6 legs. This is a picture of a honeybee. I think this is really, really fascinating because you can see insects actually do things really differently than how we do things, right? So humans have, you know, a central brain with kind of nervous support throughout. They will have kind of a central ganglia up in the head, but they will have major support ganglia throughout the body, right? So it's like if you took your brain and you kind of pieced it out and stored it along your back, right, in the different segments. Instead of having a heart that pumps blood through the body, they are like little bathtubs full of goo. Their blood is called hemolymph. It is not in veins. It is just, their organs are bathed in it. And to kind of keep the hemolymph moving and to keep it fresh, they will have basically pumps throughout their body, including at this point where their legs join their body, just to kind of keep it all moving. Instead of having lungs the way we do, they have just little holes in their exoskeleton, so in their hard outer layer that lets air diffuse through the body. So they just do things really, really differently, right? Which is actually really cool. And there's a lot of really complex structure in here that's just amazing. And so this is kind of a picture of, you know, a really typical modern insect. This is a honeybee. Insects used to be insane, right? So this is Meganeura. It's a dragonfly that used to live when it was the late Paleozoic, so it was about 300 million years ago. What happened was that the atmosphere used to have more oxygen in it, and because it had more oxygen in it, it was heavier and it could support bigger insects, which is crazy because it like kind of balanced them out better. And so this is literally how big this guy would have been, right? He's eating a salamander in this picture, which I just love. So there's kind of like insects have gone through this whole evolutionary transition. They've been big, they've been small, they've been everything in between. And what you end up with is actually something that's still really, really impressive, right? So if we think about our common fruit fly, this guy is totally ubiquitous. You're probably annoyed by him on your compost, but if you think about the fact that he has all of these structures shoved into him on a tiny, tiny scale, that's absolutely amazing to me. To give you some perspective on how small a fruit fly actually is, for many insects that are kind of fruit fly sized or smaller, when they fly, it's not flying the way we would think of it. It's almost more like swimming because the air is so much denser to them than it is to us because they're so small that they're insects that it's almost more like they're just swimming through the air, which I think is totally amazing. Some of the smallest insects, their wings don't look like flat wings anymore. They almost look like feathers, like single feathers, and it's because they're more like paddles, which I think is awesome. So there are 2 major ways to make an insect. There is gradual or incomplete metamorphosis. This is something that is found in things like mantises, grasshoppers, and grasshoppers. It's also found in cockroaches. And this is something where an insect is born or an insect hatches out of an egg and it just gets bigger, right? The body plan doesn't change really dramatically. The color might change, something like that, but right. So this is a little leaf-footed bug. You'll see these sometimes on your tomatoes. You know, it's a little orange guy. I think in this picture, he's literally hanging out on tomato, which whatever to that. They get bigger, they get darker, but the actual structure of the insect doesn't change that much. These are insects that are pretty easy, and we'll talk about this later too. If they're on your veggies and if they're really, really bothering you, these early phases tend to be very, very soft-bodied, and so some really, really easy interventions can take those out. But you know, we definitely have big friends in this group too, right? Things like praying mantises. So you got to be careful. That's in contrast to complete metamorphosis. Complete metamorphosis is so cool. Like complete metamorphosis is what got me into entomology, the study of insects, when I was a teenager. And what happens in complete metamorphosis is that the insect hatches out of the egg, builds a whole body, right? Like this is a ladybug larvae, builds a whole body, and then basically makes a hard structure over itself, whether it's a cocoon, a puparium, whatever you want to call it, essentially melts the body down and makes a totally different body, right? Which is crazy. Like if you can imagine, right? What if adolescents were not like, and then I just got incrementally bigger and like more hair. But I went into a hard case. I melted my body down. I came out with 6 legs. I came out with, you know, like a totally different structure. And so what's really, really amazing about that is if you think about it, right? So this insect, the same genetic code created both of these, right? And from the time it hatches up until this point, it actually carries a lot of the cells that will eventually grow into those adult structures stored in the body. They just hang out there dormant. They're a special type of stem cell that hangs out in the body dormant and then is activated basically when it's going through this metamorphosis. And so this is actually pretty common. There's a lot of question about how this would have evolved. Like, why would you ever have a like, and then I'm goo phase? But it did, and it's pretty common. So you have it in the butterflies, beetles, the ants, bees, and wasps all do this, and also the flies. So kind of in its most dramatic case to think about this is one I really, really like. So the parsley worm, this is one we see a lot this time of year on our dill and fennel and parsley. So it hatches out, and when it's a little caterpillar, I love this. There's an idea that this coloring, this black and white coloring, is to try and make it look like bird poop. And so it's less attractive to predators. There's an idea that it's basically bird poop camouflage. As it grows up, it realizes it can't skirt under the radar anymore. And so it grows gnarly horns and orange coloring. Sometimes it kind of does other things too. And that's to make it look big and scary and fierce, because it's essentially like just a crawling little like bag of protein, right? That's something a lot of other animals would like. Starts camouflaging itself better and better and better. And then eventually, right, it goes into the cocoon phase. This is something we all kind of know and love about butterflies. And this is that point where it's basically melting down this juvenile body and building what will eventually become the adult butterfly. So it's a black swallowtail. They're really beautiful. And it's just amazing to think that it had everything it needed to create these wings. Even in this phase, it just hadn't activated it yet. So just to be kind of, this is something I think a lot of folks don't quite realize, but across the different types of insects that do complete metamorphosis, for Lepidoptera, so butterflies and moths, we think of these as caterpillars, right? And those can come in a lot of different forms. Sometimes they're hairy, sometimes they're spiky, sometimes they're just green. In flies, these are called dipterans. It's maggots, right? A maggot is the same as a caterpillar. It's just like a fly caterpillar, and often a lot less charming. These are mosquito larvae, or mosquito maggots, I guess. And then finally, Coleoptera, these are the beetles. The beetles are the same, right? But we call these grubs, right? So these are typically referred to as grubs, although some of them are much more adventurous, right? So a ladybug larvae or a ladybug grub is a like pretty gnarly predator, right? So like it does not serve it to be shaped like this, right? It is on the move, it's getting ready to go, and even here you can see it's eating a little aphid. So when we think about caterpillars, maggots, grubs, right, these are all basically juvenile stages. They're all, you can think of them as a caterpillar basically, because most of us think about caterpillars and learn about caterpillars before we learn about any of these others. Oops. So a little bit about insects in the ecosystem. I love this, the spice bush caterpillar, who his whole plan is that he will try and look like a snake, right? So they can kind of rear up and like flash these eyes and everything to look like a snake, you know, granted a snake that long, but like maybe fearsome enough. And also they can be pretty light sensitive. So all this webbing you see behind him is because he actually had that little leaf folded all around him to try and protect him from the light. And he was rudely imposed upon for this picture. So some of the different things that insects do in our ecosystem, and it's tremendous what they can do. They help improve the soil by creating air passages, by doing all this sort of burrowing, by, in the case of dung beetles, even just taking organic matter down straight down into the soil, by being decomposers. They provide food. We will talk about this a little bit more. They are a major source of food in the ecosystem. They can be pest predators for on each other, pollinators, obviously. They make food for us, which is great. Like it is not just enough that, you know, every however many years when there's a big cicada hatch, then we all have to read articles in the newspaper about how we're going to all start eating cicadas. Like they make our food regularly. And also just beauty. And I wouldn't discount that. They add so much to our ecosystems in terms of just making them better, more pleasant places to live. So when you think about the kind of critical role that insects play in our ecosystems, it's really helpful to understand how they convey that energy, right? And so this is similar to some of what we covered in an earlier talk on ecology, but I think it's really, really important to understand how these relationships form and to understand kind of what an insect's place is in the ecosystem. So in terrestrial ecosystems, so land-based ecosystems like what we're in, all energy comes from the sun. That sunlight then hits plants. These are considered producers, and they capture the sunlight and they use it to create sugars and carbohydrates, right? So the plants are absolutely essential because without the plants, the sunlight cannot be used to create sugars and carbohydrates that then everybody else uses. So what does this look like? You have sunlight hitting a producer, a plant, that's then eaten by a primary consumer. This is going to come back and be important later. These primary consumers, plants are extremely well defended. Plants do everything they can to not share those sugars and carbohydrates they just created with anybody, right? So it's actually very hard to be a primary consumer because you have to get through all those plants' defenses for your food. Those are then eaten by secondary consumers, tertiary consumers, apex predators, right? Everybody's eating all up the chain, and all that energy came through here and had to pass through the primary consumer. And then finally, of course, there are decomposers, right? Who are going to break that back down, adding the energy back to the system. And because life is not so simple, right? It actually looks a lot more like this, where all of these energy sources are passing in all sorts of different ways. But for the most part, what's really, really critical to realize is that these primary consumers are the ones that really translate what the plants are able to do all the way to the rest of the food chain. And so they serve a really, really kind of critical linchpin role in those relationships. So what does that look like? So 96% of North America's terrestrial birds rear their young on insects, not seeds and berries, right? So when we think about bird feeders are really, really excellent for adult birds. The birds do not feed that stuff to their chicks, right? They feed insects, and typically they feed caterpillars. What they want is caterpillars, lots of them. So a pair of Carolina chickadees brings 6,000 to 9,000 caterpillars to the nest to rear one clutch of eggs. This poor researcher had to sit there and count that. But it's amazing, right? So to get a single clutch of Carolina chickadee reared, you need 6,000 to 9,000 caterpillars, right? And some of these birds are able to do 2 clutches in a season, right? So they're moving and they have to have those caterpillars constantly, and they prefer caterpillars to basically everything else. And that's because if you think about it, what is a caterpillar but, like I said, a squishy little bag of protein, which is wonderful, right? Like nothing hard to get through, nothing difficult about a caterpillar. You can just munch it. Insects are also eaten by many small mammals, reptiles, amphibians, and of course each other, right? So the insects are basically serving as the food source for everything above them, which is just amazing. And so this is what I think when I realized that, you know, even as we talk about control for our gardens and how to keep things kind of what I would consider reasonable, remember that we have to actually have a tremendous number of insects in the ecosystem for everything else to be able to do well. And so if you love your birds, you're putting out your bird feeders, which is great, but you're also, you know, knocking out all the caterpillars, it doesn't really quite work, right? It's not really consistent. And so insects can be herbivores, carnivores, and everything else, right? So this is a great picture of an assassin bug, which these things are gnarly and have these like piercing mouth parts. And I know that sounds terrifying, but they're tiny, right? Like, so it's fine. You know, this one's going for this little, probably an aphid. I don't really know what that is. It could be some sort of beetle larvae. I should know what that is, but I don't. But anyway, he's just piercing them and sucking out the goo. Of course, you have dung beetles. Anyone who's heard me talk about dung beetles before knows that I am a huge fan of the barriers, not the rollers. I think the rollers get all the press. There are a lot of caterpillar or a lot of dung beetles that will just hang out like in cow patties and pull it all down into the soil, which I think is really awesome. I'm biased. That's what I did my research in, so I'm totally biased. And then of course, herbivores. And the herbivores actually, I think, are in some ways the most interesting of the insects. And again, it's because plants are so extremely well defended. So plants have thick cell walls, they have defensive compounds, they have spines, thorns, prickles, right? So a lot of the plants in your garden, right? Like if you can imagine going out and trying to like eat a mouthful of azalea leaves, even with your big jaws and your big musculature and all this other stuff, it would be like, you know, it wouldn't be pleasant, it wouldn't be good. And insects are so much smaller, and yet they figure out how to do that, right? Which is actually pretty impressive. And for those relationships to those relationships evolve over a very long period of time, and they can be very, very intricate. So just gonna note that my internet connection is unstable, so please holler if things get weird on my end. But one of the great examples of just how intricate these relationships can be is actually with monarchs and milkweed. So milkweed is toxic. And then in addition to it being toxic, milkweed also actually has a milky sap. That's why it's called milkweed. So when you break those stems, it exudes a sticky milky sap. And it's like kind of gross when you get it on your hands, but again, imagine you had just little like mandibles that were absolutely tiny. It would be enough to basically overwhelm. And it would mean that you couldn't move your mouth, right? It would gum and lock everything up. And so what monarch caterpillars have evolved is not only have they evolved a way to handle the toxicity of the leaves, they have also evolved an ability where what they do is they know if I'm going to be eating, you know, if here's the leaf and I want to eat out here, what I can do is I can go and clip the midrib right here. That's what this is. Clips the midrib, and then that milky sap can't flow up anymore. So now all of this is safe to eat, right? And you'll see this on milkweed leaves, and it's really, really amazing because it means not only have they physically adapted to being able to handle toxicity, they've behaviorally adapted as well, right? And that is not a relationship, like a monarch caterpillar doesn't sit there and brittle that out, right? That is something that takes tens of thousands, if not hundreds of thousands of years to evolve that behavioral response. And so these are very, very close, very intricate relationships between plants and insects that have evolved together for very, very long periods of time. And we'll talk more about planting natives and the value of that moving forward. But I hope that kind of makes an impression upon you, is that these are really, really complex relationships that take a long time. And anytime a human is like, I can do better, I would just be like, oof, skeptical of that, skeptical of that answer, right? So in terms of host specificity, most insects feed on a very narrow range of host plants. So most insects don't actually feed on just anything and everything, right? Like they are not like the locusts of biblical times for the most part, right? Most insects will feed on just one or two things, maybe. So if we think again about the monarch caterpillars, they only feed on milkweeds, right? A couple different species of milkweed, but only on things in kind of the Asclepias group. Like a monarch caterpillar will sit on something else until the cows come home, but it's not going to eat it. Also, interestingly, host specificity can vary between life stages. So the monarch caterpillar is extremely picky. However, the monarch adult will take nectar from multiple different types of flowers, right? The monarch adult doesn't care as much anymore, right? Because it's just looking for nectar and sort of sugar rewards. So it doesn't care about exactly what it's on. And there are a smaller number of insects that are called generalists. These are things like grasshoppers, the cursed Japanese beetle, some aphids, where they'll really feed on just about anything, right? Like a Japanese beetle likes a rose the best, but doesn't care and will eat anything. So an example of something like this would be more like tobacco hornworms, sometimes called tomato hornworms. There is actually a tobacco hornworm and a tomato hornworm, and they're very closely related, but they're not the same, but they don't know their names. So sometimes they will end up on the other species. But even then, this is actually not that general of a generalist, right? Because tobacco and tomato are closely related. So even then, these caterpillars are feeding on things that are closely related that they know how to handle. And so for the most part, it's actually quite uncommon to have an insect that will feed on multiple different plants that are not closely related. Luckily, the one set of insects that do tend to be generalists, and this is very, very helpful, are the predators, right? So the insects that eat other insects, the insects that show up to help us keep charge of the garden, they tend to eat a little bit of this and a little bit of that. And that's actually very, very helpful, right? Because they kind of help keep things in check. So if you say, okay, that's so great, Ashley, and this sounds great, but the second part of your talk title is pest management in the garden, and I want to manage some pests. What you need to know to be able to manage pests is really what the damage you're looking at means, right? Different insects feed in different ways, and they leave different sorts of damage. And for example, I could go out to my garden and I could see a bunch of chewing damage, and I could look at it and be frustrated. And as annoying as that aphid sitting right next to the chewing damage might be, an aphid doesn't chew, right? Aphid didn't do it. And so we're going to talk a little bit about how you identify those different types of damage and what might cause them. So first, there's feeding damage. And this comes in a lot of different flavors that we'll talk about. You have things like squash vine borers that are going to go in and feed right on the stem itself, things that are going to kind of tunnel through the leaf, things that are going to cause all this like what we call stippling damage, where it looks lighter, ones that are just going to straight up eat the plant. There's nesting and egg laying. Galls, I think, are super interesting because it's basically an insect forcing the plant to make an uncontrolled growth, where typically then there's an insect developing in the inside the middle, which is like so cool that they show up, they're able to trigger growth, and then they use it as their little house, which I think is great. And then of course, some diseases. So a lot of things like blights, wilts, these kind of things can be introduced by insects, a lot of viral diseases as well. And so when we think about feeding, this is the major one we're going to be dealing with in the garden. So different insect mouthparts are really used for different types of feeding. So we first have chewing mouthparts. These are what I think of as like mandibles, right? Like typically this gesture to me, because I have a really specific reference set, I guess. I don't know. This means chewing, right? A little chewing mandible. You have piercing sucking mouthparts. This is like in the assassin bug, where what he's going to do is this long little rostrum right here, a little like poker. He's going to go up to some other poor unsuspecting insect. Like this guy looks like a predator, right? He's going to go up to some other poor unsuspecting insect and just kind of right through the exoskeleton and suck him dry. This is like a straw with a knife on the end. You have kind of siphoning or chewing lapping mouth parts. This is really common in things like bees and butterflies. So these are the ones where, you think of it as really, really classic in a butterfly that you have a proboscis, right? It's like a long, like crazy straw that they kind of unroll into the flower, and bees tend to have it a little bit more delicate or a little bit smaller than some of the butterflies and moths. And finally, you have sponging mouth parts. This is what a lot of the flies have. Sponging mouth parts are kind of disgusting because it's what, the fly lands and he's just kind of doing this on your food. And then he accidentally lands on like where the dog just was, and he's doing that on where the dog just was, right? And it's just very unpleasant. But the interesting thing to note here is that only these top ones actually cause plant damage, right? So a butterfly's proboscis or a fly's sponging mouth part doesn't cause damage, right? That fly could be there and he might be causing damage in other ways, but he's not causing it by feeding. And even then, a lot of these piercing sucking mouth parts, sometimes they're used for plants, but sometimes they're used for other insects, and that's actually really good. So the major one we run into that's really the problem causer are the chewing mouth parts. So when we think about chewing mouth parts, classic, caterpillars. Caterpillars are the ultimate chewers, right? They're the ones who are leaving all the holes that we're totally frustrated by. Beetles, both adults and grubs or larvae. So I think it's actually a potato beetle. I feel bad that I don't know this insect better, but such is life. Grasshoppers, absolutely, right? This is what we think of when we think of locusts, right? Kind of descending and chewing. And they cause this really, really, really distinctive damage, right? If it's literally just chewed off. And so you'll see chew marks and holes. Frass, that's the polite word for insect poop. So things like tomato hornworms are really big fat caterpillars that when they're on your tomatoes and they are big enough to be kind of final stage, like you can almost hear the poop dropping, like it's so big, right? And it's so kind of just, it's too big. It's too big. And finally, you'll see webbing sometimes, especially in the case of some of the caterpillars that like to tent toward the end and kind of enclose themselves, you'll see webbing. Another major type of chewing mouthpart are the leaf miners. So these are insects that feed between the top and bottom leaf surfaces. I think this is delightful that they are such divas that they can only eat the inner cells. The outer mesophyll cells are not, or like so they'll only eat the mesophyll cells. The outer epidermal cells are like not delicate and tasty enough. So they burrow their way in and they just eat all the inner cells, right? And that's why you see kind of this really interesting looking tunneling pattern, right? This was an insect that was literally just in between the leaf layers going to town. This is typically fly larvae. The damage is normally minor. Also, this is the sort of damage that once it's done, it's done. It's very, very hard to take care of an insect that is in the leaf because it's hard. It's just hard to get any chemical application there. So it's really hard to treat once it's happening. The one thing that you'll see sometimes with these guys that's even more dramatic is you'll start seeing these sort of swelling, and that's because he's in the leaf, he ate out all around it, and then he started growing, right? So this is kind of, if you were to break this open, you would see a grub probably in there. I guess a maggot, because it's a fly, you would see a maggot, so an immature fly in there kind of just like getting fat and happy off of those inner leaf cells. Another major thing that some of the chewing mouthpart insects can do is leaf skeletonization of leaves. So the previous ones we saw, right, they wouldn't eat the cells on the outside, they would only eat the inside cells of the leaf. These guys will eat all of that, but they won't eat the veins, right? So they'll eat epidermal leaf tissue or leaf tissue except leaf veins, right? So this is all of the veining of the leaf just kind of left. This is another one that is kind of both gnarly and mesmerizing at the same time when you see it. It has a lace-like appearance. It can be really delicate. This is really interesting. Again, it's another thing that kind of, it's largely cosmetic once it's happening. As long as the entire plant isn't affected, there's not much you can do about it because again, the plant can't regrow that damage. And finally, in this group, you have the borers. So these are going to be mostly beetle and moth larvae. They feed under the bark on the stem and the wood tissue. So they literally bore in, they lay their eggs, and then typically it's the immature forms that are growing up inside the plant. And so this will be things like your squash vine borer, where your squash vine is big and beautiful and you love it. And you come out one day and it's wilted, and no matter how much you water, nothing can be done. And that's because there was a butterfly, or there's a moth, but yeah, so there's a moth that lays an egg at the base of the squash vine. That little borer goes in there and just eats the very middle of it, right? And so it eats all of that connective and kind of vascular tissue in the middle. Also things like southern pine beetle and ambrosia beetle. Ambrosia beetle is something that might become more and more of an issue on our crepe myrtles. You'll come out, and if you see a crepe myrtle and it's got all these holes in it, or sometimes it even has what looks like little toothpicks sticking out the side, if there are too many, can be bad. And this is one of the things that's really hard about the borers is you'll see things like sawdust, holes, tunnels. They can introduce disease in a lot of cases because then the disease gets in through the holes, and oftentimes death. And there's no good treatment because oftentimes the insect is so far into the plant that there's not an easy way, even if you wanted to do an insecticide, to access it, right? Like the insect is deeper than you can get. So these can be really kind of devastating insects. I would typically say, especially if you saw a plant that was wilted from squash vine borer, pull it up and throw it away. Cut your losses, right? There's nothing that can be done at that point for the most part. For some of the piercing, sucking mouth parts, these are not the predators. These are the ones that are eating your plants. They have basically a proboscis, so like a specialized feeding structure that penetrates plant tissue to extract fluids, right? So they are trying to get all those fluids, those sugars, everything else that is kind of moving through the plant, they're trying to get those. That's what they're trying to feed on. This can lead to discoloration. And that's what happens when they basically remove cells containing chlorophyll. So that's what you see kind of here, right? So this is really, really typical on some azaleas. They can get this because of azalea lace bug. Stippling, so tiny spots, leaf bronzing or yellowing, right? All of this, oftentimes you'll see this on tomatoes after they've had a lot of leaf-footed bugs on them. One of our state entomologists thinks that leaf-footed bugs are getting a bad rap and they're not actually causing this. Something else is causing it, but I don't know. But I know it tends to show up when the leaf-footed bugs show up. And finally, distortion. And that's because they often inject compounds to keep the phloem, or so that sugary plant water, moving, right? So they want to keep the good times rolling. So they'll basically inject things, and that will cause distortion of the plant. And that's kind of what you can see down in this corner down here, where these upper leaves are really kind of getting weird and mottled in their shape. Two of the major symptoms you can see with piercing, sucking mouth parts are honeydew and sooty mold. And you will not know kind of what you are looking at until it becomes clear in your mind, right? So honeydew happens because the insects that like to feed on the phloem sap, they excrete a sweet, sticky substance. And so basically what happens is that these insects are trying to get enough proteins and sugars out of the plant. And they're typically getting way more sugars than they need for the amount of protein that they want. So they just keep going and they start shooting the sugars at the back end, right? And that's what leads to honeydew. And you'll literally the leaves will start being sticky and kind of feeling weird. And it's because something up above is letting out a bunch of honeydew. And so it's going to be things like aphids, mealybugs, whiteflies, some of the scales and some of the plant hoppers, and it can attract ants and wasps. And so sometimes you'll go out and you'll see a plant and it's like swarmed in ants, and then you touch it and it's sticky. The ants didn't make it sticky, right? There's probably an aphid infestation that's causing the stickiness that now the ants are coming to. Eventually, that can give rise to sooty mold, which is a fungus that grows on honeydew. It's this black that you might see on leaves sometimes. It blocks the sunlight, which is really problematic because then those leaves can't do what they need to do. Horticultural oil can often help because really what you're trying to do is you have to address the aphid or mealybug problem here, which will then address the honeydew, which will take care of the sooty mold, right? So you see the sooty mold and you go, oh my God, I have to take care of this black. And it's like, no, 2 steps back is what you need to take care of, right? And horticultural oil can really help with that. Another major problem you can have is egg laying. This can cause a lot of damage. So some of the gall-forming insects, again, I just love this. I think it's so cool. So they lay eggs in the plant tissue, and then when that little egg hatches, the larvae release hormones to induce a tasty plant tumor, right? Which is super cool. So they are basically causing the structure to grow. And you're going to see this in some wasps, flies, and mites. Flies especially, I feel like you see this in pretty commonly. I think it's just amazing. There are also twig girdlers, which I think, again, like insects, so ingenious. What the twig girdler does is it goes along and it basically girdles the twig. It makes it so that it will die at the twig tip, and it lays its eggs in that portion that will die. It drops off, and then it has like a perfect little fresh twig for its eggs, right? And so if you ever come out and you see under your trees, you see like perfectly cut looking little twigs, right? I pick those up and get rid of them because they're full of twig girdler eggs. But I do think that that's pretty ingenious, right? That they kind of know exactly how to do that. They usually don't cause serious damage. They can cause some problems on pecan, but for most of us, we're not carefully monitoring our pecan production to the point where we would notice that. But if you are a big time pecan grower, you might become aware of that. And one of the really big things insects can do is really disease transmission. So things like fire blight, which is really common on a lot of the fruit trees, is really spread actually by pollinators. It's a bacteria spread by pollinators. Or something like tomato spotted wilt virus is a virus that's spread by thrips, right? And it's because if you imagine, right, they are basically like little needles and they're going around needling everything, right? And that is not good hygiene, right? That's not helpful. And so over 200 plant diseases are spread by insect vectors, mostly viruses and some bacteria, some fungi. And they're spread either directly or indirectly. So either by feeding or by wounding. But sometimes even just the wound is enough that if the disease is in the area, now it has an easy place where it can get in. So plant it and they will come. When you're thinking about insect management in the garden, if you say, okay, I've got a lot of chewing damage, so I think I've got probably like a caterpillar or something like that, right? That it's really easy to get to that point and then go, okay, so then I need to kill the caterpillar. What I would actually say is I think that that's a really good moment to consider your options and to think about, do I know what's causing the damage and how do I feel about that? So is an intervention even really necessary? On a lot of plants, it's not. We're not looking for perfect plants. We're looking for plants that are within kind of an acceptable threshold of damage. Perfect is never going to happen. Perfect is not how life works. Acceptable is possible, right? And then finally, what is the least invasive, still useful option, right? So I always like to think about what can I do that's kind of the least invasive option that still gets me the outcome I want. So there are a couple of major types of intervention. First, there's cultural. Really, really important, preparing soil to promote healthy root growth. I would say that the vast majority of insect and disease problems I see are actually cultural problems. The plant is not healthy. And because it is not healthy, insects and diseases are finding it and taking advantage of that. And so to some degree, no matter how much I try to fix the problem in terms of fixing the insect problem, it's a deeper problem and it's going to keep coming back in one way or another. And that's one of the most frustrating parts of gardening is often not knowing what's going wrong. But typically it's that you don't have the right plant in the right place. And that is a trial by error sort of thing. And I know that's frustrating, but gardening is like a lifelong learning experience and we kind of figure it out as we go. Another thing you can do, especially when it comes to things like fruits and veggies, is crop rotation. Insects and nematodes and other things can absolutely build up in your soil and build up in your garden. And unless you're rotating your crops, that will just keep getting worse. And when I'm saying rotating, I don't mean grow peppers one season and grow tomatoes the next season or the next summer, because those are both closely related crops. I mean growing peppers and then growing kale and then growing peas, right? Growing distantly related crops in the same space. Interplanting can help to some degree. There's limited evidence that things like some species of marigolds can help with nematodes in the soil. That's a little bit, some of it has good research, some of it does not, which is not to say it doesn't work. It just means that we don't have the research to back it up right now. Kind of African marigolds and nematodes are one of the clearest examples we have. And finally, planting dates. So here in North Carolina, there's kind of, for example, two schools of thought on when to plant tomatoes. Some people like to plant them very early to try and avoid the insect and disease pressure that comes late in the season. And some people actually like to plant them a fair bit later to try and avoid the cold weather that comes at the beginning of the season, right? So you're kind of balancing multiple things. We have really good planting calendars for North Carolina, but they are typically like wide windows when to plant, and you kind of have to decide when in there to do it. But a lot of people do like to plant things slightly earlier to try and avoid disease and insects in the middle of the summer, which is really our harshest time of year. From cultural interventions, we go to mechanical. So this is going to be things like hand picking. For things like aphids tend to hang out in little parties on plants. There is almost nothing more effective in my mind than like a good hard spritz of water. It does a remarkable job. It works extremely well. It feels obvious and it almost feels like you're cheating. It's so easy, but it does a really good job. Things like barriers can be very, very effective. So these are row covers placed on veggies. You want to be careful to not have these on when the plants need to be pollinated. This is kind of something that can take a little bit more work, right? Where you have to put your row covers on maybe when you see the insects coming and when you start noticing a lot of insect damage, and then you have to remove them, but they can be very, very effective. Pruning and raking is actually really, really helpful. So in things like what we talked about earlier with the twig girdlers, getting all those girdled twigs up is really, really useful. Removing damaged tissue, kind of removing all of that is really good. There's hardly ever any reason to leave damaged tissue on a plant. It just kind of serves as a place where disease can get in. Water spray we mentioned earlier. This is one that I think is like fascinating. They're not insects, But things like slugs and snails cannot climb over copper, because copper basically short circuits their little electricity, like their little bioelectricity, right? And so they can't go over copper. And so a lot of times people will put copper barriers out, and it helps with what I consider like the, I don't know, the slimies, you know what I mean? Like slugs and snails, they're not insects, but so that can help really, really well with that. Of course, biological intervention, so things like parasites, predators, and pathogens. This is something that I think is really, really interesting because oftentimes, for example, with things like aphids or any number of different things, if you only have a couple of them, they're not actually enough to attract the predators. But you reach a certain threshold where you have enough that the predators are like, lunch, right? Like that's worth coming over to check out your place for lunch. That's a hard place to wait for, right? Most of us do not want to wait for enough aphids that all of the gnarly wasps that want to eat them and take them over for their babies show up. But that is something that will happen eventually. And that was also something, as we talked later about developing kind of a well-rounded ecosystem in your garden. If you have a well-rounded ecosystem with a lot of different insects, a lot of things will start balancing each other out. And you will start attracting predators. You will start attracting any number of different things that will help you on your side, right, of keeping some of these things under control. This is a great picture. This is a Japanese beetle, which everyone's like, no. That little spot right there is a fly egg. It's this fly, it's a tachinid fly, and it will parasitize this, right? That egg will hatch and it will eat this Japanese beetle. So nature has a plan, even for Japanese beetles, right? Sometimes we just have to wait for it. And finally, when it comes to chemical intervention, you really do need to know what you're dealing with. You need to know what the insect you're looking at is. This is a classic example. So first off, you have to know what the insect is, because you have to know what it is to know if the chemical you're using is appropriate, right? I can't use a chemical that treats aphids and mealybugs if I don't know if I have an aphid or a mealybug, right? That makes kind of sense. But the other thing is there are a lot of things that look pretty gnarly and scary, but are actually very useful, right? So this is a ladybug larvae picking off aphids, right? So this thing looks wild, right? Like it's orange and black and kind of scaly looking and kind of, I think, cool, maybe just some gross. And it's eating aphids. But if I saw this and I sprayed it all, everybody here would die, including my friend, right, who's helping me do the work. You need to time applications appropriately. It's really important when you're using anything to try and avoid basically when a lot of the pollinators are out. So it's good to be basically at dusk when a lot of insects are settling. I would actually argue, and I thought about not including this, but sometimes people want like just real answers. I think that most things in the garden that need to be handled can be handled with either insecticidal soap, which is really good on soft-bodied insects in some of those immature or juvenile phases, or with BT, Bacillus thuringiensis. It is one of our oldest organic insecticides. It's actually derived from a soil bacteria. It was derived in the 1930s, and it works primarily on caterpillars, right? And so things like tomato hornworm and cabbage loop around your cabbages, those little white butterflies, this will work really well on. And you can basically put it on your veggies especially, and it will knock out caterpillars. I like it because it you only put it on your veggies. You don't put it on everything else, right? Caterpillars have a right to be on most of the other stuff, but you do want your tomatoes for you. And I think that between the two of these, I know that in my own garden personally, I use insecticidal soap, I use BT, and for virus or for fungi, I use copper, a little bit of copper soap. I don't use anything harder than that. And I don't find that I need anything harder than that because I really work on keeping my plants happy and healthy. And for the most part that works. And for the plants that I can't keep happy and healthy, because like none of us are perfect, they typically get replaced with someone who will be happy and healthy, right? And that's just kind of part of the process. You especially want to make sure you stay away from dusts. So things like 7 dust, just because they transport really easily, and it's very, very easy for things like bees to pick them up and take them back to the hive, which is not what you want. Absolutely, absolutely, absolutely always fully read and follow the label. The label is actually the law. Make sure you read it, make sure you follow it. You can be that person in the big box store who like opens the label, who breaks the plastic to open the label, right? Like I give you permission to do that. So I'm thinking through one of these situations. I want to know how serious is the problem. And that depends on the age and the size of the plant, how much of the plant is affected. And finally, younger plants are more vulnerable. So typically older plants that are more established can fight things off. Plant parts that are attacked, right? So leaves are not that serious. Every leaf gets some damage at some point in the season. Stems can be more serious. So if I see stem damage, I'm more worried about that. The health of the plant. So is it healthy and is it non-stressed, or is it already having trouble? It's going to have a lot worse infestation if it's already having trouble. Is it ornamental or edible? So our edibles, we like to keep nicer looking because we want things from them. Our ornamental plants, I would say I would tolerate a lot more damage on. And finally, does it persist over a few weeks or several months? So the longer the insects stick around, the more damage they can do. So for a lot of these insects, actually, they're only out for short periods. It's whenever their kind of period of the year is. And so even though they can look pretty bad, over time it will go down. And so I often like to wait and see a little bit to see if the infestation will die back. And so with that, I'm going to say that we should take our break. Let's take a break for 6 minutes. Let's come back at 7:05. And we'll try not to answer too many questions while you're gone. So please feel free to go to the bathroom, get a drink of water, yada, yada, yada. Monica, I'm going to pull up the chat so I can see what we've been up to.
You go for it. There's not been a whole lot of activity so far. Great talk, as always. I have to ask you if you were saying copper soap for fungi.
Yeah. So I use a copper it's technically listed as a fungicide, but it does actually work on some bacteria as well.
Okay, so that's, and I did just put the name of Bacillus thuringiensis out there so that they knew what BT stood for. And that was it.
And I'll talk a little bit through BT as well when we come back. I actually think it's really cool how it works. So I would love to talk about that.
DE, I don't usually have a problem remembering how diatomaceous works because of what it's made from. So of course you get the sharpness that's kind of slices them up on the inside. But the Bacillus thuringiensis is an endotoxin, but I don't know if it actually paralyzes the creature or because somebody asked if it starves them to death. And I'm like, I don't know about
it's more like it explodes them, but I'll talk about it anyway. So wait, Wanda, are you raising your hand?
Yeah.
Nice.
Yeah.
What you got, Wanda?
Did you say copper soap or copper spray?
It's copper. I think of it as like a copper fungicide, which sometimes is labeled as a copper soap. But it's like if you went to a store, it looks like one of the hippy dippier ones, and it will be like copper fungicide or copper soap or something like that.
Copper fungicide, about $10.
Yeah.
For a concentrate.
Yeah, it's
okay.
And I don't even buy a concentrate. I tend to buy premixes because I realized I don't use them fast enough. And I hate to admit this, I'm a very lazy person. And so if you're like, hey, mix up this concentrate, I probably don't have the right measuring spoon in a pesticide dedicated measuring spoon. And then I'll start eyeballing it and hoping for the best or being like, it's just copper, we'll be fine. And I just don't trust myself.
No, but you're right. You don't use enough of it to, and what is the shelf life of that? What is it doing to the plastic container it's in?
Yeah.
And all kinds of issues.
What is the shelf life?
It's probably on the bottle, but I would imagine I have found with coppers that after a year or two, they settle out so much that even when I shake them real hard, I don't feel like I'm getting them back in solution quite appropriately.
And you may not be.
For my tomatoes this year, just because you said to do that. So
yeah, so I think you're good for a year or two. I mean, again, lazy gardener, right? I'm not going to go out and buy it new. I'm going to use up whatever I have, but I typically use a bottle within a year or two.
Yeah. Ashley, this is not an insect, but have you heard of Asian jumping worms?
Yes.
Oh my gosh. I'm seriously concerned, man.
They've been here a really long time, actually.
Oh, okay.
I had someone who sent me a message and was like, what are you going to do about this? And I was like, well, I can't go back to the 70s. So they're
Now,
just
I don't
here.
know if there's anything we really need to do about it. I don't think it bothers me as much as the hammerhead worms, which will kill. Those things are
The
freaking-
tetrodotoxins. Well, Wanda has heard
Yeah.
me rant about this before, about how the vast majority of worms here are not native, including what we
Yeah.
think of very fondly as our like wonderful earthworms that make soil.
Man.
Most of our worms were knocked out in the last ice age.
Right. The Pleistocene, something.
Yeah, and so like those gnarly jumping worms, where everyone's like, they're predators and it's terrifying. I'm like, they just came to eat the food that showed up already. Like, you know, like, because so many of our worms are Asiatic.
Right. And I have no idea that we actually need to do anything about it, except, I mean, like, I'm not sure what they're hurting. I know that they're not producing the worm poo and aerating the soil and producing the poo where we need it to be. It's on top. I don't understand how it's not disintegrating into the soil. All right.
It is. But I mean,
Right.
that's the thing, right? Is like, even, I mean, so this is like a story that like will always stick with me. So my dad grew up on a farm in Illinois, and all of, you know, he remembers growing up, and it's the Midwest, right? So they have that really thick prairie topsoil, and the folks would say things like, oh, without the worms, we never would have such good soil. Like, we have these amazing soils because of the worms. And like, he's gotten really into natural history, and he was like, the crazy thing is, if we have the worms for too long, we won't have that topsoil, right? Like, they eat that.
Right.
And he's like, that topsoil could actually only form in those areas because you did not have organisms actively breaking it down. So
Wow.
yeah, I think we have interesting conversations, but I just realized in telling that story that maybe it's interesting to a select type of person.
Well, yeah,
So
no,
should-
I thought it was interesting.
Should we kill those hammerhead worms?
Can we get a shotgun and start shooting worms?
No. So,
it doesn't- I mean,
somebody
it
in my subdivision who lives in the absolute lowest spot, every time it rains, and this was 1 year. I don't know that she still is having this problem. She could pick up 100 of them at a time, but this was
Oh.
the absolute lowest point off the sidewalk in front of her house.
And that's what I would
Right.
say is that, like, you know,
You can't do it.
that's between you and your God, right? If you want to kill them, that's fine, but there's nothing that can be done about them at this point.
Yeah, if I see them, I kill them. I mean, I just don't want them. I don't want them, but there's nothing. I'm not hunting them.
So so many of these things are, you know, the cow's out of the barn, right?
Right.
And there's nothing we can do. So, all right, we are at 7:06.
Oh, all
This-
right. So let's just work the questions for just a
Okay.
second. We did confirm that you did say copper soap for fungi.
Yes.
And Diane happened to add that she found a Fertilome copper soap fungicide online. We talked briefly about leaf miner damage on vegetables like spinach, and that it was okay to eat that. And you
Yep.
hope that it's already gone. The bugs are already gone. But you can't have enough of it, I think, for you to consume enough insects to make a difference. And stomach acid has a purpose
Protein.
for its existence as well.
Protein.
Yep. Well, that's a joke, but no, I don't want it anyway.
And so for BT, for the Bacillus thuringiensis, my understanding of how that works is that the stuff you buy commercially is actually an isolate from BT. It is kind of the active portion, and it's almost like diatomaceous earth in that it is very, very jagged. And so what it's doing is it's actually breaking down the insect's stomach all the way out. And so I like to think of it as exploding their little stomachs. But I think that's kind of brutal. And the point that someone made that's very, very important is that it is not selective about caterpillars. It will take out a monarch, it will take out a cabbage looper, it will take out a swallowtail.
Yeah.
It won't
Alright.
take out an aphid, but it will take out any caterpillar. So just be really smart about that. And that's why I would say to be very, very, I would only apply it for myself on veggies, fruits and veggies.
Yeah. Andrew wants to know if the hammerhead worms regenerate if cut in half.
I don't know, but I'm gonna
I
look
don't
it up
either.
because I want to know too.
Carolyn wants to know if copper soap is okay to use on roses.
Yeah, typically copper soap, if you're seeing fungal if you're seeing it, it might do it. Roses are kind of gnarly. And so I wonder how super effective it would be on things like black spot, but it's worth trying. One thing I'll say with copper soap and with insecticidal soap is make sure you're getting the undersides of leaves, because that's where a lot of where a lot of fungal and insect damage is actually happening.
Sawfly larvae on your dinner plate hibiscus. Holy crow. You have to start on those things early, but I think the worst of the infestation is gone. At least where in my yard.
Yeah. And so for the question too, about lots of ants all over the squash plant leaves, they might also be being attracted to something from the squash itself. So I would check for stickiness on the leaves. Like I would literally do this. And if I don't see that, there are a lot of plants that basically start exuding sugar at certain times to try and attract pollinators. So you might be okay, right? So this is like peony blooms. I don't know if you've ever noticed peony blooms get swarmed by insects, by ants especially. They just kind of attract them when they're flowering.
I thought they helped them open the blooms.
Evolution, right? Like, I love it.
They don't seem to bother it. All right, getting back to the subject at hand.
Oh, what did I just do? Did something just happen for you guys? Sorry.
No, we're still looking at getting to know the neighbors.
Okay, great. So I am going to just a minute. I need to figure out what just happened with. This is fun. Zoom just had a feeling with me. Okay, I'm going to stop my share for just a second, you guys, so I can just reset, and then we will be back at it, because I don't want it to be confusing for us. Talk amongst yourselves.
So how long are consumer mixed chemicals good to be used before not being effective? And I think the answer there is to see if that information is on the label.
That's absolutely right. That is absolutely, yeah, you just look, all of that stuff will be written on the label. And I would just check that, and typically I'll say it. I mean, it's like how even, right, cosmetics, they always tell you, it's just all of us always ignore it and are like, whatever, 5-year-old mess.
Yeah, I think every year, what few chemicals you need to buy, you need new ones of. Wanda, did you need something? Wanda?
I got her. Okay, so can you guys see this? See the slides?
Yep.
Okay, cool.
Organizing insects.
We're back in business. Thanks, guys. So, okay, so organizing insects. So this is kind of a fun section. We're going to talk a little bit about what some of the major insect orders are, and we'll talk about their mouth parts specifically. This is when we think about insects, just the way as when we think about plants, even when we think about different types of soil, right? They are they're best thought about if you kind of understand roughly the organization of the different insects that are related. And so insects, when we talk about them, most of the time we think about them as being organized in orders. So orders always have the suffix ptera, because that's easy to say. And it's the Greek word for wing, and you'll see what I mean about that in a second. But it really describes the wing anatomy. And so don't worry about this. I understand this is a lot, but for an insect nerd, it's beautiful. So this is where you have things like I have another screen over here. That's what's happening. All the mantids, right, are in Mantodia. All of the cockroaches are in Blatodia, right? All the flies are in Diptera. And it's really helpful to know kind of what these larger groupings are. And so we're going to go over what an entomologist would call the big five. These are the 5 orders with the most diversity, with the most species, starting with, no surprise, Coleoptera, the beetles and weevils, right? These are the ones where the creator must have had an inordinate fondness. So these are the largest group of insects, over 300,000 species worldwide. That is a very conservative estimate, might be 400, 500, 600, right? We have 24,000 plus in North America, and they're a third of all animal diversity, right? So beetles, we just live in it. They undergo complete metamorphosis. So they're going to go from grub all the way up to beetle. They have chewing mouth parts, mandibles. So they are herbivorous or predaceous typically. So they're either going to eat plants or eat each other. In the case of a dung beetle, they're going to eat poop, right? Like they're going to do a little bit of anything. If you are a third of animal diversity, you are going to be diverse in what you eat. They have 2 pairs of wings. For them, the outer wings are called elytra. They are really interesting. So these are these lower wings that we think of as normal, and these are the elytra. The elytra are little hard structures that allow the beetles to be kind of like little tanks, right? That's what's really cool about them. It also means they kind of fly like little tanks, right? So beetles are not really particularly good flyers. They're good diggers, they're good scrappers. Flyers, they're doing the best they can, but like they have other charms. The grubs are often underground, and the adults often fly around. But like, you know, you can see a beetle coming because he's kind of like doing his best. So some of the major coleoptera, oh, I was right. Sorry, it was a potato beetle. Some of the major coleoptera that you might know about as being kind of like nemesis would be things like potato beetles, Japanese beetles, certainly, right? These can harm turf and lawn as grubs, harm everything as adults. Pro tip, never use a Japanese beetle trap. It just attracts Japanese beetles to your yard and you don't empty it often enough. You would have to be emptying it constantly for them to not build up in there. What's going to happen is it's going to fill up, still attracting Japanese beetles. Why do you want that? Why do you want a Japanese beetle beacon in your yard? The granulate ambrosia beetle, this is one of those beetles we were talking about where they basically burrow in, lay their eggs, and you'll see the holes. You'll see sometimes the tiny little toothpicks of sawdust behind them, and then cause a lot of damage. Second most popular, we have the Lepidoptera. These are called butterflies and moths. There are more moths than butterflies. Butterflies are actually kind of just like day flying moths, right? We think of it the other way, but that's actually how it works. There are over 180,000 species worldwide, with over 11,000 species in North America. They also undergo complete metamorphosis. Their caterpillars can come in kind of every shape imaginable, right? From normal looking to extremely furry to, you know, terrifying to touch because they cause terrible stings, right? Like everything you can imagine. Their mouth parts, larvae have chewing mouth parts, right? So they do that sort of caterpillar damage that we expect, but the adults have a coiled sucking proboscis or no mouth parts, right? So if you think about some of these guys, there is a very, very large moth, big, beautiful moth called the Cecropia moth. I mean, like it's like a good sized moth. Cecropia moths have no mouth parts because they expect to live a short time and try to mate, right? Like they are going to try to mate so hard, they got no time for eating, right? So they don't need mouth parts, which is crazy. But so this is why the same insect can cause tremendously different amounts of damage in its life. They have two pairs of uncovered wings that are covered in scales. This is actually really amazing. So, you know, it looks like a flat surface, but if you were to touch it, it almost comes off like dust. Some of the really, really amazing, beautiful blue butterflies that you might see in the tropics, things like the blue morpho. The blue, this is a crazy fact. The blue is not actually even a pigment. It's not like there's actually blue there. It's a structural pigment. And what that means is, you know how when you used to look at the back of a CD, it like shot back all those colors at you that were not on there, it was silver. That's because of the way that the CD was shaped and all that data that was carved into that, it would basically shoot back colors just because of the way they got broken up in there like a prism. The blue morpho, this bright blue butterfly, doesn't have any blue. It just breaks the light up like a prism and shoots back blue at you. It's a structural color, just super cool. Yeah, I just think that's a fun fact about structural colors. So moving on, the third biggest order are the dipterans, the flies. We have 155,000 species worldwide. They definitely undergo complete metamorphosis. This is a picture of one mosquito larvae eating another species of mosquito larvae, right? Mosquitoes are flies. They're just terrifying, terrifying flies. They have piercing, sucking, or lapping and sucking mouth parts. Piercing, sucking is what gets them in trouble, especially when they're piercing and sucking us, I would say. They have one pair of full wings. That's actually where their name comes from, diptera, diptera wing, 2 wings, right? Instead of most insects, which actually have 4 wings because they have 2 full sets. So what the flies have instead is they have what are called halteres. And these back here on the crane fly, this is not a mosquito. Don't kill these because they look like massive mosquitoes. They're crane flies. They mean you no harm. These are the halteres. They are super, super modified wing structures, and they actually work really well like super good rudders. And so in all the ways that the beetle is not a good flyer because it decided to make some of its wings into little tank shells, the fly is an excellent flyer because it dedicated one whole set of wings into just becoming like little like specialty rudders. So that's one of the reasons they're such excellent flyers. And many mimic other orders, especially the Hymenoptera, which we'll get to in a minute. And so up here, you'll see a large bee fly. That's a fly. That's not a bee, right? Like that's pretty cool. So the flies can look like bees, especially. They can look like all sorts of different things. And this picture in the lower left-hand corner is just because I wanted to give a shout out to fruit flies. Fruit flies, love them, hate them, however you feel about them. They are in one of their forms, the species Drosophila melanogaster. It is one of our absolute most important scientific resources. So much of what we know about biology and so much of what we know about what it means to be an animal comes from fruit flies. They have given their all to the cause of research. So like, thank a fruit fly the next time you do anything that involves basically any type of biological science. A fruit fly probably helped. And finally, we have the Hymenoptera, the ants, bees, and wasps. I believe that their name comes from the fact that their wings are often these very, very kind of membranous structures, these sort of hymen structures. So Hymenoptera, right? Membrane wing. We have over 150,000 species worldwide, over 500 species of bee in North Carolina alone, right? And so we all think of honeybees. There's so much more to the ants, bees, and wasps than honeybees, right? These also undergo a complete metamorphosis. They have biting or sucking mouthparts. Stings are not bites, right? Stings are not bites. Stings come from the back end of a female Hymenoptera, typically. So fun thing is that, for example, with carpenter bees, these are the big ones that show up in the spring and like want to get in your face, even though they're on your property. That's fine. They don't know. They don't respect property law. They, the ones that typically really want to get in your face, if you can ever look them straight in the eye, if they have a white spot on the face like this, that actually means they're male. They don't have stingers. Only the female bees and wasps have stingers because it's a modified egg-laying structure. They have 2 pairs of wings. So you can kind of see here that there's a second pair of wings underneath. And they range from truly social to solitary. So by eusocial or truly social, what I mean is things like the honeybees, where you have a queen and you have a whole bunch of bees that don't even reproduce, and you have intricate caste structures and intricate social structures, all the way over to something like the carpenter bee that hangs out by itself, or some of the ground nesting bees that nest in the ground by themselves. And the way that you can always really tell a Hymenoptera more than anything else, the way you always know if it's an ant, bee, or wasp, is they have these super pinched little waists, right? So if you're ever noticing that there's an insect swarm and you're like, is it termites or is it flying ants? Flying ants, which they both tend to swarm around the same time of year, actually this time of year, the ants will always have these really pinched little waists, whereas the termites will look almost more like grains of rice. So this is really, really, really kind of almost diagnostic for the Hymenoptera, that they have these super pinched little waists. Oh, we have one more, sorry. We were only at 4. So finally, we have the Hemiptera. This is a huge group. It's the true bugs. Do you know not all bugs are bugs, only the true bugs are bugs? The true bugs, aphids, whiteflies, scales, and cicadas, over 80,000 species worldwide. These are the first one we're going to talk about that go through a gradual metamorphosis. Some even reproduce asexually, like some of the aphids reproduce asexually, which is a worst case scenario when you think about aphids, that you don't even need 2 of them. One of them could infest you. They have piercing, sucking mouthparts. All hemipterans have piercing, sucking mouthparts, and they can cause a lot of damage. Some are wingless, some are immobile. But if you think about like this sort of stippling damage you might see on an azalea, that's an azalea lath bug. If you think about the honeydew and sooty mold, that's going to come from scales, things like aphids, right? All of these are insects that are going to try and pierce in and suck out the parts of the plants you want. So hemipterans kind of punch above their weight in terms of damage. One thing I will point out is that, again, just because you see an insect on a plant doesn't mean it caused the problem. Kudzu bugs, for example, they are hemipterans. They're true bugs. Kudzu bugs just like to party. So they will show up in large numbers, but they really typically like to eat kudzu and other legumes. So this is a huge mass of kudzu bugs on a fig. They're not doing anything wrong. They're just hanging out, right? And so it's always worth really kind of saying, do I actually see damage on the fig or on the plant? Do I actually see something I'm concerned about beyond just a mass of insects, right? Because like these guys are just like doing their thing, right? No intervention required. just a lawn party. So always worth really thinking about what you're looking at and trying to figure that out to see if you even feel like you need an intervention. And that really brings us to kind of our last section. And this is all about learning to live together. So this is a great picture of an ant farming, I believe some little aphids or scales, which is great. Yeah, not just humans farm, ants farm too, which is amazing. Like they will even kind of delicately take care of their scale insects because they're trying to get all that honeydew. Like if it starts to rain, they'll move them under the leaves. They'll do all sorts of cute stuff, which is really nice. So when we think about insects, I think most of us fall into two camps. One of us are either like, oh, insects kill them. The other camp, and I bet a lot of you are actually in this group too, is, oh my God, what's happening to the insects? If all the insects die, we're screwed, right? Like a lot of angst is going into insect decline. This was an article that came out in 2018 in the New York Times Magazine called "The Insect Apocalypse is Here." So this is a scary one, right? So this one at the top, it showed basically how much insect decline we were having. In response to that, there was an article in The Atlantic, is the insect apocalypse really upon us, right? So this was kind of a response to what this article showed, which was they were showing that there had been a lot of decline, that there was a lot of drop in insect numbers. These folks were basically arguing that maybe some of the science wasn't great, maybe some of the data wasn't there quite the way the original authors had said. What I found really, really interesting about this conversation, and you might have even heard the phrase insect apocalypse, is that if you read that second article, if you read that article from The Atlantic, they actually quote NC State's own Dr. Elsa Youngstedt. And as they try to argue that the insect apocalypse is not going to be that bad, this is what Dr. Youngstedt said. They're the most diverse group of organisms on the planet. Some of them will make it. That does not make me feel better, right? Like that does not actually calm the nerves the way that maybe these authors had hoped. And so what is actually really going on? What is the science showing us about insect populations and insect numbers kind of globally? So there is actually a lot of evidence of decline. So this is from a study from Science Magazine in 2014. And I'm going to walk you through this. So don't worry, like we're going to handle graphs together. What they've done basically is they have taken some of the major insect orders, the ones we've talked about, right? Coleoptera, beetles, ants, bees, and wasps, moths and butterflies. Odonata is the dragonflies and damselflies, and Orthoptera is the grasshoppers and katydids. And what they did was they said, okay, if we look at these insect species kind of globally from a whole bunch of different research, right? So they get a bunch of research studies together and they compile them and they look at them. They say that most of the species in red, we find evidence of decline. In green, we find evidence of increase of those species, and in gray, no evidence either way, or it's stable. Mostly red for a lot of things, right? So especially for the Orthoptera, the grasshoppers and katydids, you see a tremendous evidence of decline, if not 100%. For the beetles, ants, right? The only insects that are under about 20% for species decline is going to be things like the dragonflies and damselflies. And even then you're talking about 1 in 5 species showing evidence of decline. Similarly, if you basically were to just smush all the insect numbers together and then have all the other invertebrates, right? You were to say, is there decline? So from 1970, right, this is going to be years on this axis. This is going to be kind of an index of decline with 1 being stable, right? This is increase, this is decrease. The butterflies and moths are all showing evidence of decline, right? They're down at about, I would say, 65, 70% where they used to be. All the other invertebrates are going to be down much lower than where they used to be, right? We're seeing this is baseline. This is what we would have expected from 1970. Here's where we are now. So there's really, really strong evidence of decline. In fact, there's an average decline of over 45% across observed insect populations. And the way we know this is that there are a lot of researchers, I even briefly worked at a research station that did this, that have been going out and doing these sort of censuses every year for 30, 40, 50 years. And so they can come back and say, you know, this year compared to 50 years ago, we are seeing a strong decline and we're seeing the trend in every year in between. right? So this is not just kind of like pie in the sky. Maybe it's happening, maybe it's not. It's like, no, we have hard data to show this. The kind of classic example most people cite is that when you were a kid and you went out driving in the car, the windshield got disgusting. I just drove through the cicada emergence on the East Coast, so my windshield got disgusting. But other than that, I haven't had a disgusting windshield. I don't know the last time. I might and I'm not saying this in any sort of way, but I might be young enough that I have never seen a truly disgusting windshield the way some folks have. And it's something that I think a lot of us very viscerally have experienced. Why is this a problem, right? Remember this, that these are our connectors between like the world of producers and everybody else. So some of the effects of the decline that we can see already. In the US, we know insect services are valued at about $58 billion a year. What do I mean, insect services? I mean, they support a $50 billion recreation industry. This will be things like fishing, birding, any of these things. Actually, you really have to have insects to support those industries. Otherwise, like the ecosystem would collapse. 4.5 billion in pest control. So insects just eating other insects, so we don't have to do anything about it. Pollination services worth about 3 billion. This is just all those bees that are trucked around, right? Bees are literally trucked around at this point. Solitary bees do a lot of work too. Dung beetles alone save ranchers about $380 million a year in cleanup, right? If someone's going to roll off the poop or bury the poop, that is nice, and it's something the rancher does not have to take care of, right? So these are very, very human-centric ways to view the value of an insect, but even then, it's tremendous, right? These insects are basically keeping the world together, right? In some of your intro science classes, you might have heard this idea that if the decomposers stopped decomposing, we'd be buried in trash in like a week, right? If the insects stopped doing what they were doing, we'd be done. And so this is all pretty scary. And I think that most folks get really, really alarmed when they hear this. And the idea, or the question I think pretty immediately becomes like, what's causing the decline? Like what's causing the problem? Do we have a good sense of what's causing that? And this is another really cool study on monarch decline. So this is actually research that came out in 2019 this is someone I actually used to work in a lab with, and this was a paper that came out that was really elegant, where what they were really interested in understanding was what had caused monarch decline. So much of us think, okay, monarchs are declining because milkweed is declining, or because of GMO crops, or because of blah, blah, blah. And they wanted to say, sure, those are ideas, let's actually test it. And so they went back through and they looked at historic data on monarch numbers and milkweed numbers. And what they found was that in 2000, which is basically just after 2000 actually, which is when 50% of the cropland was in genetically modified plants. There was a clear evidence here, right? This is a downward line, so you can see milkweed is going down, monarchs are going down. And so if I were to say, okay, I'm gonna look at this one little snapshot, you'd say, oh no, GMO crops, milkweed's going down, monarchs are going down. That's scary, right? View these as kind of separate graphs, but what you're really looking at is that trend, is that angle of that line. You say, oh my God, no. But if you go back, what becomes really interesting is that actually that monarch decline has been going on for a long time. It's been going on since about, right around the 1960s. So that's not a decline that happened because of GMO crops. That was a decline that continued despite GMO crops. And it's really because the milkweed's been declining that whole time, right? And what's even more interesting is that if you go back even further, you'll see that the monarch decline peaks in the 60s and the milkweed decline really takes off just before that, right? So what's really driving the downward monarch numbers? It is the fact that something happened to the milkweed 10 or so years earlier. And this is a period, right? This is the period of the 40s, basically, when we start getting into really large scale mechanized agriculture, kind of modern agriculture, the way we're doing it. And there's a lot of supporting research to show some of the causes of this decline, not just as it applies to monarchs, but as it applies to so many different types of insects. So what are our major causes of decline? Habitat destruction and degradation. So if you think about what's killing the milkweed is being killed, they think, largely because milkweed used to be able to grow in between all of the small crop fields, but as crop fields get bigger and as they become consolidated, those inter areas are no longer there. There's no room for the milkweed. If there's no room for the milkweed, there's no room for the monarchs, right? Pollution, especially including pesticides, and these are in rank order, so this is the most important. This is the second most important. biological factors, so just kind of changes in biology, changes in ecosystems, and finally climate change. Climate change is very important, but actually what's drawing a lot of our contemporary insect decline is straight up habitat destruction and degradation. So as cropland with a lot of spaces in between it gets replaced by big fields, and as kind of wild areas get replaced with lawns and cities and everything else like that, the habitat becomes so fragmented and so destroyed that the insects just, they don't have room, right? They don't have space anymore, and the populations start declining. So how can we help, right? What can we do to make things better? I would start by encouraging you to really, really think through, what does pest-free really mean? There are so many absolutely beautiful plants that they're selling right now, but some of them just straight up take your breath away, and they'll say they're pest-free. And that sounds great. Until you're like, wait a minute, why can't a pest eat this? Right? And the reason typically that pests can't eat these plants, sometimes it's because they're toxic. So in the case of the Mandarin on the left, right, it has toxic berries, but oftentimes it's because they are non-native, right? And just like we think about that monarch and that milkweed, and how that monarch caterpillar has to have all those special evolutionary adaptations that came along with growing up with the milkweed, when you introduce plants that are not native, the reason they might be pest-free is because none of our insects know how to eat them. And so they just don't provide any real value in the ecosystem from a supporting insects perspective. Pest-free means, of no use in some ways, right? Beautiful, but useless. I like to think of these plants as being like sculptures. Some of them are absolutely great in the garden, but I don't actually want a sculpture garden. I want a garden with maybe a little bit of garden art, right? So all things in moderation. I wouldn't have too many of these sorts of plants in the garden. You do you. I'm just saying that's what I would do. Really, it's better to focus on native plants and pollinators. So a lot of these are pictures from the Pollinator Paradise Garden in Chatham County that agent Debbie Ruse has. It's really phenomenal. And she does just the most amazing, beautiful plantings. And they work basically from spring to fall. They have good winter interest. They're beautiful. They're interesting. I'll show you a list of them in a minute. And you can have some really stunning combinations that support a tremendous amount of insects, because that's the crazy thing, right? Is insects are tiny. They're tiny, right? So if you want to set up a national park for elephants in Africa, in Southern Africa, you have to have a lot of space. Elephants are big, right? If you want to set up a park for ants, you don't have to have nearly as much space, right? So your own yard, your own garden can actually be a really, really good reserve for those insects, because think about it, like you can have like 5 ants on this one little thing, right? Like they don't need as much space. So we can actually set up these sort of, as Doug Tallamy, kind of an excellent entomological researcher says, these homegrown national parks, right? In our very own backyards. And you will attract some of the coolest, most beautiful things. So even this, it's actually just like a shield bug laying eggs, but the eggs are iridescent, right? They're like metallic iridescent, they're beautiful. Or this was a picture that one of our master gardeners sent me, Mark Powers, he's a beekeeper, so he was a little bit annoyed, but he has these shield bugs that set up right on his beehives, and they'll just grab the bees right out of the air and eat them there, and kind of tear them apart and all it's gnarly, and it's like, it's like a lion on the Serengeti, right? It's really, really cool and really interesting. And this is being set up just in people's yards, in these sort of common spaces in small areas, right? You can do a tremendous amount in a small area because insects are small. If we come back to this idea of host specificity, even though most insects are specialists, there are a number that are generalists, and there are a number of plants that support a tremendous number of insects, right? So plants that really tend to support large numbers of species, insect species, our native oaks often support 400, 450 plus different species of insects. So if you have an oak, keep it. If you have an open space and don't know what to put in it, can I suggest an oak? There's a million different types of oak. You'll find one you like. It's great. I will talk you through it. Blueberries are wonderful and actually support hundreds of native species. Things like goldenrod and sunflower can provide nectar and benefits for pollinators, even in weird times of the season. So, goldenrod and sunflower especially come on a little bit later in the season when it can be hard for insects to find the resources they need. And for things like monarchs that are migrating, they really need those resources. So there's a lot you can do. I will send out lists. If you guys have seen these talks before, I'm just like, look at this list. It's the most amazing thing ever. But there are some really, really excellent resources about how you can find native plants that are beautiful. They do what you want, and they support just a tremendous number of insects. Planting across seasons is extremely important. So complete habitat supports all life stages, right? So you want things that are going to support the caterpillars, the young caterpillars early, the caterpillars as they turn into cocoons, and then the animals as they're migrating through, right? The sort of monarchs are the classic, but so many of our pollinators need late season food, and things like asters can really do that. And one of the best ways to have a good diverse planting is, so those beautiful pictures we saw earlier, right? Those are all from Debbie Rue's Pollinator Paradise in Chatham County. Debbie made it easy. She just went ahead and put together a list of her top 25 native pollinator plants for North Carolina. This is a slightly like sun favoring list, but it's amazing because she says, you know, here's the spring blooming ones that I think are bulletproof and perform extremely well. Here's the summer blooming, here's the fall blooming. Here's how you find them. And on the back is here's how you find supplies. And I'll send this all out, right? So what I would do is if I was trying to get started, I was thinking maybe I want to support some native insects. I want to support them because A, they're great. B, they're the basis of our food web. C, they're going to show up and eat all the stuff I don't want, right? They're going to do work for me if I can attract them in. You might start by picking just 2 or 3 from each season and adding them into a single planting, right? It would be a beautiful bed. It would bloom from spring to fall. These plants are known to be pretty resilient. They're known to perform well, and they're native, and they're going to support so many of our native insects and beyond, right? They're going to support birds. They're going to support amphibians, everything. If you want to take it one step further, right? These are some of the really, really excellent resources we have for finding native plants. I want to give a serious shout out to the North Carolina Extension Gardener Plant Toolbox. This allows you to even dial in and say, I want a plant that's this size, blooms this time, is this color, is drought resistant, is, you know, blah, blah, blah. I want all these things. And they'll say, have you considered this plant? You know, and that's really, really helpful because you can just dial in exactly what you want. And finally, go ahead and make it extra inviting. Right? There are other things that insects like just beyond just plants. Bug hotels are adorable and they're fun and they're interesting and they really work. So this is a way of basically having, you know, this is like a lotus pod, like a poppy pod, sticks where the beetles can be. You also have holes of different sizes. It does kind of matter what size the holes are. If you stick between like 1/4 of an inch and 5/8 of an inch, you're typically good. You can buy these pre-made, you can make them yourself. They're really fun. There's a bunch of directions online. I'll share some of that. And a lot of what they provide habitat for is solitary bees. And so I have 2 at my house, and they're really cool because these different little holes, the solitary bee comes and like lays their egg, and then they cram it up with dirt. And then they'll lay another egg and cram it up with dirt, right? And so that's where kind of the eggs hatch. But you'll see that you can almost say, based on the different colors of soil, they're clearly going to different parts of my yard because they have slightly different colors of soil and they're finding different resources. And that's really cool. On a larger scale, something like a brush pile is actually really, really, really effective. Provides habitat for any number of things. You can get frogs, box turtles, insects, any number of things hanging out in a brush pile. I like to think of this as essentially a lazy person's compost pile, right? Like you just kind of pile it all up. You forget about it for a while. After a while, you kind of go over and just nudge it a little, see what's going on, right? If there's too much activity, you leave it alone. If it seems like no one's home, maybe you could use it as compost, right? It's kind of a self-solving problem. Allowing some amount of weed in your yard. So this is the plant that we were talking about earlier. This is, Monica, you're gonna laugh at me. I don't remember if it's purple dental or henbit. They're sister species. They are leaves attached slightly differently, but you can see there's a bee on this. This is
I don't think it matters.
It matters. It does matter. Evolution matters. So this is a plant that will explode in your yard early in the season. You know, it's that kind of sea of purple that we all have in March. And there's a bee, right? Happy as can be. So these are some plants. Clover especially is another one they love. Tolerating some amount of weed in your yard. I heard a speaker one time who said weeds, or as I like to call them, wildflowers. So some amount of that is definitely good. Some amount of open soil for those who just straight up struggle with lawn, like myself, is also great because many of our native bees are actually ground nesters and they need open exposed soil. So these little mounds are not terrifying fire ant mounds, they are bee mounds. And they're solitary bees, so they don't like to sting, right? When you think about a hive of bees, like honeybees, they'll sting you because a lot of them don't care, right? Like their whole job is to protect the queen, that's their job. A solitary bee is every woman for herself, right? There is no queen to protect. She is her own queen. She doesn't want to die over you, right? So for the most part, solitary bees are not going to give you a hard time if you don't give them a hard time. leaving things like branches, dead trees, snags, anything that you can tolerate supports a tremendous amount of ecology. It supports, lichens, mushrooms, insects, anything you might imagine. It's really, really good. A lot of birds will also nest in dead trees. And finally, adding water in any way that you can, whether it's a bird bath, this is actually a bubbler, so water's coming out here, going down and being kind of recycled around, whether it's a fountain that's kind of mild, whether it's a pond, it can be a bird bath up to something much more intricate, but insects love it, birds love it. They all are absolutely attracted to that water, especially in some of the hot, hard months of the summer. So there's a lot of ways you can do this. I know that it can be really, really frustrating to insect damage on fruits and veggies. I am certainly very frustrated by it. I am not above putting down some insecticidal soap. I'm not above some BT. But what I really think about is that there are kind of places in my garden where I am more regimented about keeping the insects at a minimum. And that's really my raised beds where I grow my fruits and veggies. And then there's everything else, which I kind of think of as the place where, this is not my garden, I wish it was, pollinator paradise. This is the space for us all to kind of work together, right? And so if I see a plant that's struggling, I really need to think about why is that plant struggling, not just what is the insect that's eating it today. And I think that if we can kind of work with the insects, we can support them, we can support our native birds, and we can support so much of our native habitat and create our own little homegrown national parks full of insects. And so with that, I am going to take any questions, and thank you all so much. Monica, do we have any questions?
We do not have any questions at the moment, but I wouldn't be surprised if some roll in as we finish here. I'm grateful for the native species. When I became a master gardener, Ashley, I discovered that I thought I knew something, and then after I got finished with becoming a master gardener, I had to redo my yard because I didn't realize how many mistakes I was making. And then I heard you talk about natives, and now I have to redo my yard because I wasn't. And actually,
we're just gonna have to go out and buy more plants.
I have plenty of grass. I have plenty of grass that I can get rid of every year by putting in more native stuff. So that's always a helpful suggestion. Someone who couldn't make the end of the meeting did ask if it was going to be able to be viewed later, and I told them yes, and to check the website for that.
And I will send out the link to everyone who is registered too. So we definitely have it. Yeah, we definitely have it available.
Awesome. Stokesia, did I see that on the list of native?
Stokesia laevis.
Yeah.
I believe she has it as one of her, sorry you guys, I'm gonna do this.
There it is. Stokes aster. So it is a Stokesias, but I assume that more than just Peachy's pick, any Stokesia would probably be.
Yeah. So yeah, absolutely. So Peachy's pick, and it's named for Peachy, not for the color. Peachy's pick people like because it's got a tidier habit and doesn't spread quite as aggressively as some of the other Stokes asters. For example, I know Wanda had a Stokes aster that she said spread really aggressively, and she gave some to me reluctantly, and I was like, that's great, I want an aggressive spreader, which is always like the fateful last words of somebody who doesn't realize what an aggressive spreader is.
No, they do, but they're worth it.
Yeah, and I had some next to some that I knew was a verified Peachy's pick, and I think they're a little bit different, but I'm still waiting to see if that plays out, but I think it's more of a, yeah, Peachy's pick people like just because it's a little bit more polite.
Do you know whether or not ice plant, which now Delospermum maybe is what I think that is, my pollinators love that stuff. Of course, like any perennial, it can be a little invasive, but it's, I never see it on the lists of native because they can be invasive, but they seem to love it. Fascinating.
Okay, so I will admit that like part of this, I don't actually know I don't actually know the native range of that plant, but a native plant can't be invasive because so it can be a thug. It can be an aggressive spreader, and it can have a lot of feelings about the fact that it's going to take over your garden. But an invasive plant is inherently a non-native plant that is also, that spreads easily. So, and you will get the PowerPoint and resources in an email. Sorry, that was a question that's through the chat.
I see it.
Yeah. So anyway, a native plant can be what I like to think of as a thug or an aggressive spreader. And part of what he discussed, he's a really kind of excellent landscape designer who works a lot in kind of natural landscape design.
Who is this? You froze right when you told us his name.
Sorry, Larry Weiner.
Okay.
Yeah, really excellent. And so part of what he pointed out that I thought was very interesting is that in our native plants, we have aggressive spreaders, we have polite plants, you know, we have kind of everything in between, like, you know, shrinking violets. And so if you put two aggressive spreaders next to each other, they tended to actually do quite well, right? They balance. If you put two polite plants next to each other, they do quite well. It's when we put our aggressive spreaders and our polite plants next to each other that we have problems. And so it's all kind of just knowing even about how the plant grows, you know what I mean? Which is like one of those things where let's all hope we all get to live to be like 400, because I don't know how we're going to learn all of this in one lifetime, but we're going to try.
God, it's a lot.
Yeah. So,
well, I'm grateful that there is a lot of these flowers that we're seeing on these lists are available at most of your nurseries and a few of them at your big boxes. These are very easy to grow and easy to get to spread, however, not aggressively. You know, the bee balm, that's not, but not a stoke aster that really can take off. But if I want it, then I also don't mind going out and digging it up and potting it for other people to put out as well.
That's funny.
Purple coneflower. I don't know that my pollinators know the difference between the purple and all the other colors that I happen to have. So I'm kind of hoping that
They kind of do. Purple coneflower is one of the most fascinating ones. If you're just don't ever get multiple like weird bloom shapes, and all of a sudden the insects are like, I don't want anything to do with this.
Yeah. Well, my purple coneflower threw up something that's throwing up little tiny heads in one of the blooms. And I'm like, what happened to you? But the rest of the purple coneflower is fine, but they go to all of them.
Yeah.
Oh, and there's your spotted horseman. Now, you know, I know it's a Monarda, but somehow it's something that you're going to love.
Weird color changes, weird flower shape, spots, everything I need in a plant.
Oh, there you go.
If it had thorns, I would be even happier, but like it is very close to being the perfect plant.
Speaking of which, there's blue vervain on this list, which that stuff, it can absolutely take over. It may be native, but it can get.
It's aggressive.
Yeah, you can get out there.
I think that her list actually veers slightly aggressive, and it's because like these are things like you're gonna have a hard time killing this. Like it's gonna survive whatever you throw at it.
I'm not trying any Joe Pye weed. I don't care.
Yeah. That's funny. Debbie Ruse named one of her first dogs Joe Pye weed.
Love it.
So
love it.